All right, so hi everyone, and welcome to today's SQL Office Hours session. It's great to be back here, new year, new challenges. Hopefully you're keeping safe and well and healthy and everything's not too crazy wherever you're based in the world. Today we're going to be talking about a really common topic, something that comes up pretty frequently. If you've seen any forums anywhere, certainly once a month, but quite often weekly, people ask some variation on the question of, I've got some data as rows, and what I want to do is turn it into columns, right? So we've got this row data, we want it to turn it into columnar data, is that term. And probably one of the most common reasons for doing this is taking date-based information as rows and turning it into columns. So for example, you've got orders or invoices, whatever they are, with date-based information, and what you want to do is transform that into column information. So instead of having a row per date or whatever it is, you have a column per week, per month, per year, and so on and so forth. Very common to have this kind of request. There's lots of the types of forms this request takes as well, but this is the most common in my experience. Take some dates, turn as rows, turn them into columns. And we've got a really handy pivot function in Oracle database to do that. How to use it? It's nice and simple. You do select from your query, your table, whatever it is, and then you've got the pivot clause, and there's three things that you want to place in there. So there's the aggregate function. So that is the totals you are computing for each row. So that could be counting, summing, average, whatever, the traditional aggregate functions you all know and love. So counting, sum, maybe min or max, averages tend to be the most common. And what we want to do is compute that for a column we are pivoting on. And for the values in that column, we want to produce new columns in the output. So the columns that we appear in the output are ones we list in this values clause. So for example, if I want to show, instead of rows per customer, what I want to do is have columns per customer. So I want to show how many orders each of them have placed. I want to count the number of orders for each of these customers, and we'll say customer ID 1, 2, and 3. So we'll slap those values in. Count for customer ID in 1, 2, 3, like that. Pretty straightforward, right? Well, there are some various little gotchas and things to be aware of in this, and there's all sorts of ways we can extend it to. First thing to note here is that this customer ID, the thing we are pivoting on, must be a column. It cannot be an expression. So that's going to be a really important concept. I'll get to explain a bit more in detail when we come to pivoting dates, transforming dates into months or years, that kind of thing. The second interesting thing is that there is an implicit group by clause in this statement for all the columns that you in your source table that are not in the pivot clause, right? So quite often this gives you unexpected outputs. So if you've got your orders table, you probably just want maybe full customer ID. That's the only thing we want here. There's the other stuff on there like the primary key, the order date, shipment information, who knows what else. Those other columns will inform an implicit group by for this data set. Probably not what you want. So there's a few things we might want to do here. We might want to apply a function to this column, and we want to remove this implicit group by. There's only some columns we want in the output. So to do that, what we need to do is access the table in a subquery, and then here the subquery will do any formatting of the pivoting columns and restrict the output to just the columns that we want to pivot on or in our final results. So what I really like to do is use the with clause, call it rows, call it whatever you want, and select the columns that you need for the pivot clause, any others that you want in your output, and do any formatting of them. So we'll do the kind of restriction of the data set here. Now, you don't always need to do this, but in my experience, it's very rare you don't want to do this, right? Usually the table has more columns than actually you want to include in the output of your pivot. So at the minimum, usually you need to restrict these like so. So fairly straightforward. Have your subquery, which selects and formats your columns as appropriate. Say which function you're going to, what your aggregate function is. Are you counting how many rows? Are you summing up some values and so on? Which is the column you are pivoting on, and which of the values in that column should become the new columns in your output. So fairly straightforward, but there's ways we can take this a little bit further. One of the things is you might want to add extra calculations to the output. So previously we had the number of orders placed for each of these 3 customers. You might also want to have sum up the total values of them or something as well. You might want to have multiple aggregations that you want to calculate, right? So we don't just want to know the total number of orders placed each month, but we want to know the total value of orders for each month. So for example, we'll have, instead of just January, February, March, April, May, and so on, the number in there, we'll have January count and January total, sum of the value. So we'll have 2 columns for each month. So we need many aggregates. So this is pretty straightforward as well. All we need to do is just keep listing out more aggregates in the start of the pivot clause, so in that first section of it. And you can put a whole bunch of them on here. However, if you have more than one, it is one thing you need to be aware of. You need to add aliases for those functions to all except one of them. I'd recommend you add aliases to all of them, but you have to have aliases on all except one of them. If there's 2 or more without aliases, the query will fall over. You'll get an error. So you need to alias those. And those aliases will be appended to the names of the columns that you generate in the output. Again, well, I've got some demos coming, which will hopefully make this a bit clearer and show you how it all fits together in a bit more detail. So we can have multiple aggregates that we calculate. Next thing you might want to do is pivot on many different columns. So before we were just counting on customer ID, you might have 2, 3, 4 columns that you actually want to pivot on. And the good news is you can do this too. This gets a little bit more fiddly. In the for clause, you just have a all comma separated list of all the columns you want to pivot. And in the in clause, you've got to have pairs of values or bracketed values for matching the number of columns you're pivoting for each set of values that you want to expose. So this is something that makes a lot more sense in a demo. So at this point, that's enough kind of like just walking through some theoretical syntax. Let's look and see how these actually look in practice. So I'll jump over to SQL Developer. And what I'm going to do is use my customer orders schema. So this is our new sample schema that we created a year or 2 ago now. And there's just basic information in here, our primary key, date, customer, status, and so on. And as I said, what I want to do is for the first 3 customers, 1, 2, and 3, I'll generate columns for them and count how many orders they place. So if I do just a plain pivot like that, what did I say about all the other columns not in the pivot clause? They form an implicit group by. So you can still see we still get order date, the primary key, and so on and so forth in the results as well. And another interesting thing here is, although I've only pivoted for the column, the customers 1, 2, and 3, we're actually getting all the rows from the table. You can see there's quite a few here rows where none of the customers have placed that order. They're for a different customer other than the ones we've specified here. So we want to remove all these other columns, so we're not getting those in the output, and we might want to filter the data as well down to just these three people. Okay, so before while we're talking about that pivoting, this point might go, well, how do we filter data? We add a where clause. Now this is where things get a bit interesting. Where do we put that where clause? Well, the pivot clause, the table is the input, is the direct input to that clause. So we can't actually put a where clause in between here to filter it down to just these 3 customers. You'll see we've got an error there. So that's failed. You can filter the output of the pivot. So we do where customer in 1, 2, or 3, but the output of the pivot is removed customer ID from the results and turned it into those 3 columns, 1, 2, and 3. So if we try and do that, it's going to fail as well, because at this point, that customer ID doesn't exist. If we want to filter it down to just the rows where at least one of these customers made an order, we need to filter on the output of these columns. So if we get that, and then we can see there's one in at least one of these. So you'll notice something interesting there. I've had to double quote the names of these, 1, 2, and 3. And that's because by default with Pivot, it takes whatever value this is and turns that into a column name. And identifiers, column names in Oracle database cannot start with a number, right? In order to use that, you have to put the double quotes around them. If I try and reference this without 1, it's actually looking at the literal value 1, and it will do that because 1 is greater than, it's checking is 1 greater than 0, not is the column with name 1 greater than the value, has the value of 0. And you'll notice we're back to having some rows with all these zeros in. So again, that's probably not what you want. So a few things we want to do here. We want to remove all these other columns from the output. We don't care about those. We possibly want to filter the result down to, filter the data down to just these 3. And we want to have some more meaningful column names. So as I said, we want to do some of that in a subquery. So we'll use our subquery to select only the column we need in the output. That's customer ID. So now if we run this, we can see we've now got just our 3 columns. We've removed all those other ones from the result set. So we've got just the rows and the total number of orders each of those have placed. So quick note on the filtering here. You see, I put my where clause in this. I can remove it and we'll run the same thing and we'll get the same results. So 5, 2, and 10. I can go back and we'll see that's exactly the same, 5, 2, and 10. It is a very good idea to do this filtering within the subquery, because without it, this is still processing, the pivot clause is still processing all the data in the table. There's a couple of thousand rows here, and there's only like 17 in the results. So that's doing a lot of unnecessary work. It's still counting up all the others effectively, or processing all the others, even though we don't use them in the output. So a good general principle with SQL, or data processing in general, is filter the data as soon as possible. So by filtering it on the subquery, we're only processing those rows which have these values, 1, 2, and 3. That will help with performance. You know, if you particularly you've got a large data set and you only want a small subsection of it in your output. And then you'll see I've aliased the columns as well, cus1, cus2, cus3. So we've got more better, more friendly, usable names in the output. So quite often you'll want to do that, particularly if you're just using numeric values, but often the values in the source column don't truly reflect the output that you want in the results. So various things we've done there to help improve how this works. So I'm just, so I see there's a question or comment from Hachemi. Select star from Unpivot, count some cell for depnum in. I'm not sure what have you got a question about that, Hachemi, or is there something that are you just making a statement? Could you clarify, if you could clarify exactly what it is you're asking there, that would be great. Thank you. Okay, so Uma Shankar, is it possible to use in value dynamically? I will come to that in a bit. I'm going to spend some time talking about that, and it's a very good question. We'll just stick with this for the minute. Okay, so we've got our data, we've filtered it down to just the rows we want. Okay, now as I said before, this value here has to be a column. It cannot be an expression. So if I wanted to do that kind of date conversion, taking the order dates and turning them into month column totals, I cannot do something like this, to-char of the value to get the result out. It's just going to fall in a big heap and give me some error here. So what I need to do is pre-format this column in a subquery to actually do this conversion, this to-char conversion. So we can run this, and what I'm going to do is get that for each month, and we now see from January to June. So there's a problem with this result. So I'll give you a minute to think about what is the problem with this result is. It's not just because I've only got the first 6 months of the year. That's partly because I was feeling a bit lazy and don't want to type all the other ones out, and partly just to make it a bit easier to actually see what's going on here. If you've got, all the 12 months of the year, it gets a bit tricky to kind of spot what's actually happening. So we've done the data conversion, data formatting in the subquery, and then we can use that column we've defined there in the pivot clause. So if you need to do any formatting here, you need to do it in that subquery. So it's really, really useful to use this. But as I said, we're getting the totals for each month, right? Some of you are probably thinking, what's the issue here? What's the issue with that? Well, problem is I'm getting every row which has the value January, right? What happens if our data spans multiple years? And in fact, the data here does span multiple years. I'm getting the total across many years. Every single January, no matter which year it falls in, will be in this total. So this total could be 1 year, could be 2 years. We don't actually know at this point. We don't know how many years this data spans. So at this point, we want to take advantage of the implicit grouping that we get from Pivot and add a year column to the subquery. So I'll just show that as is. So you can see what I've done. I've just got month and year now. So I've pulled those values, extracted them out of the date column itself. But I'm only referencing the order month in the pivot clause. So this order year becomes an implicit group by. Effectively, there is a group by order year thing here, right? You don't see it, but that's effectively what we have. And you can see, there we go. We've now split the values out per year. So the implicit grouping you get, sometimes it's a problem, but sometimes it is exactly what you want. So the key thing here is to ask yourself, which columns do I want to appear in the output, and which columns am I going to use in the pivot clause, right? And all of those you need to specify in your subquery. Anything else, if it's not in the pivot clause and it's not a regular column table or formatted one that you want to appear in the results, exclude it. Otherwise, you'll get implicit groupings going on. Okay, so that was the simple case so far, where we're just getting one total for each month. We're just counting how many orders there are per month. Might also want to get the number of different customers there was each month. So not just the count, but the count distinct customer ID. And like I say, doing that is pretty straightforward. We just add in the extra aggregates, but notice we've now got these aliases on them as well. And these will then get suffixed on the end of these of the aliases we defined for the new columns we're generating. So you can see we've got January orders, January customers, February orders, February customers, March, and so on and so forth. Like I say, we can remove one of these and it will still work. We just get Jan. We can't remove both of them. We will now get an error. Column ambiguously defined. I'd recommend just aliasing all of them, but you don't, strictly speaking, have to. You have to alias all except one of them. Okay, so now moving on. So that's the multiple aggregates. Let's move on to the multiple pivot columns. So pivoting on 2 columns in the output. So what I've got here is, again, just year and month and customer ID. And I'm actually going to try and pivot on customer ID and order month. So notice I've got pairs of columns. So what I need to do is specify pairs of values. So what this is going to give me is, for customer ID 1, how many orders they placed in January, for customer 2, orders in February, and so on. So we will get just 3 columns in the output. Each pair becomes 1 column in the output. So it's not that often that you need this, but there are times when you do need to do it as well. So we can see this first customer has only placed 1 order in January. That was in 2019. Second customer only placed 1 February order, and so on. So it's the combination of customer ID and month. Okay, so it's, if I want customer 1's February orders in here, I have to add another pair in here. So this, you can imagine this gets pretty fiddly quite quickly. I don't see many people doing this. I don't see many people needing it particularly, but it is very useful to be aware of the times when you do need it. So that was the kind of the quick demo. I'm going to jump into some more details. Any questions or comments at this point before we move on a bit? So, see, FJ, could these sample queries be shared along with the video later, please? Yes, I'll upload the script to Live SQL and I'll add it to the resources on the office hours page. So when you kind of, you can come back to the page later and there's some extra links and I'll add that there. So yes, I'll make these available to you so you can have a fiddle around with them. Any other questions or comments? Like I say, we're going to come to the big main one. Okay, so Hachemi, can we get select cus1, cus2, cus3? Hang on, I think I'm going to have to cus1, cus2, cus3, sum of cus plus 1, cus3 from pivot in cus as cus2, cus3. I think I know what you're asking there, and yes, you can do things like that. I'm going to come to that in a minute. So stay tuned. I'm going to discuss some other things you might want to do. If I haven't answered your question shortly, then let me know, okay? But yes, I'm going to discuss something related to that at the very least. Okay, so that was pretty straightforward. But one of the big things here is, in order to use this, you need to know which values you want to become the columns in your output, right? And for things like months of the year, it's pretty obvious. We can just list them all out fairly statically. But for other things like customer IDs, product names, that kind of thing, you don't necessarily know in advance what all the values you want to become columns are. You'd like to run a subquery. So probably the most biggest asked question is, can we do a dynamic pivot so that essentially we have the values that we are generating the results for based on a query, right? Most common question I get related to pivoting. And as many of you probably know, if you try and run this query, what happens? Well, you get an error, right? Right, yeah, okay. You can't just put a subquery in that in clause and it do what you want it to, generate columns with those values. And sadly, there is no perfect solution. There's no one solution to this which really, suits the bill and does exactly what you want. There are various ways to kind of achieve it, and they've all got their various pros and cons and drawbacks to them. So I'll go through them quickly. Now, first up, there is actually a really neat trick you can use which enables you to put a subquery in here, and that is an XML pivot. So you just do pivot and then the XML keyword after it. And the great thing about this is you can then actually put in a subquery to define what the values are. And you could even use the keyword any as well, in which case it just looks at the source values, the values coming out of the table or subqueries, and uses those to generate the column values as well. So on surface of this seems brilliant because it auto does it for you. What's the drawback with this? Why doesn't everyone use it? Well, the output is in XML, right? You don't get a whole bunch of extra columns in your results. No, what you get is one column, which is XML data. And the values that we are pivoting on become the values of the elements in the XML itself, right? So on surface, at first glance, this seems perfect, but in practice, it doesn't really do what you want to do. Now, in order to actually take those that values or that data and turn it into columns, you need to process the XML. Now, maybe your client-side tools are able to do that for you in some automagic way, but it's very difficult to do inside SQL. If you're using this in other queries or other data processing that you need to do, because the values that you want to become columns are the values in the attributes. And you need to know what they are in order to do something like use XML table or some other XML conversion routine to turn those into columns. So you kind of need to have run the query that's, generating your values to actually get them out. And it's all a bit of a chicken and egg problem. And so, like I say, it seems brilliant, but generally doesn't do what you want it to do. And I've seen very few people who seem to actually really like this solution or go, yep, that's exactly, I'm happy with that. This is exactly what I wanted. Some people may be okay with it, but in my experience, generally people go, yeah, okay, I can work with it, I have to, but it's not really what I wanted. So what else can we do? Well, instead of an XML pivot, what you could do is kind of come up with fixed columns, or I call them numbered columns. So in your subquery, if you can assign row numbers to the source data, then use those row numbers in the output. So for example, as I said, one of the most common reasons for pivoting is taking date values and turning them into columns per week, per month, per year. So instead of having the names of the months, January, February, March, we just get the values 1, 2, and 3, or however many columns you want to do in the results. So in the subquery, we're going to use row number, rank, dense rank, whatever, to assign those and pull them out. So the nice thing about this is it's kind of a query kind of template where we can just kind of put the information in. And, you know, if you've been listening to me talk about SQL macros at all, which I think are an amazing feature, we could use a SQL macro to do something like this. The real downside of this is we've just got meaningless column names. The columns are just called 1, 2, 3, 4, 5, whatever, however many we've actually specified in the output. And it does what we want, but if you're giving that directly to, you know, end users, they have to do some thinking. They have to know what the start value is. You know, is 1 January, or if I was looking for the past 3 months worth of data, is 1, you know, whatever, November last year, that kind of thing. People need to interpret the data, and clients might need to interpret the data. So it does generate the columns for you, but you need to do some extra processing and thinking about it to give you what you want. So is there a way where we can just have a query and generate the columns that we want in the output based on some subquery, for example? And the answer is yes, but in order to do that, we need some form of dynamic SQL. We first run a query which generates a comma-separated list of what the values actually are that we want to become columns, and then we place that in the pivot clause using dynamic SQL. So the good thing about this is we get the columns that we want. Well, I say the columns we want because we have got that first query to generate the comma-separated list. Turning those into meaningful column names can still be a bit tricky. You know, we saw if we were just looking at customer ID values, 1, 2, 3, the numbers 1, 2, 3, and so on. Aliasing those appropriately in a subquery so they give you a meaningful name or the name that you want could still be a little bit fiddly. But probably the biggest drawback is that we're now running 2 queries, the query to generate column names and the actual pivot itself. And generally speaking in SQL, when it comes, you want to have one query that processes all the data. As soon as you start running 2, 3, 4, 5 queries, it tends to get slower. So it's there's a performance aspect of that side of it, but particularly with this approach, if you've got highly dynamic data where you're going to be generating different column names pretty much every time, then you're going to have a lot of parsing overheads. You're going to have a lot of different SQL statements. And this could really hurt your system if you're going to be running this, doing this a lot. So kind of does you what you want. It is a bit fiddly, and potentially it can really slow your system down as well. So at this point, I'm going to go back to my demo and show you how those kind of all work. So let's start off with the naive approach. We want a dynamic pivot. I want 3 months worth of data in my output, so January, February, and March. I've got my query which generates those values. So we'll just put that in the values clause, right? Run that, and whole thing falls over, missing expression, error. We can't do this as is. However, as I said, I can stick this lovely little XML keyword in here, and the whole thing will just work. We'll get the output as XML. But as I said, we've just got one column in the output. It's probably not what you want. Just make it a bit easier to see. Let's run this in script mode, hopefully. So there we go. We can see for each year what those totals are. And as I said, the actual values, the column headings, are values within the XML elements as well. So kind of knowing what these are, extracting them out, it's a bit tricky to turn these into columns. Maybe I'd love to hear what people think about this. If you've got thoughts or comments, please say. But I find most people are kind of like, I don't like this, right? Okay, so that's the XML pivoting. Next thing is, I said we're going to use like just number the column headings 1, 2, 3, 4, and this is something that's kind of doable with dates. So what I'm going to do in a subquery here is for each month or year month, I'm going to assign a row number. Okay, so January's 1, February's 2, March is 3, and so on. And we are sort of giving those row numbers in that subquery. So we've got the values 1, 2, and 3, and we're going to pivot the result of those. So this kind of gives us what we sort of want. We got 3 months worth of data, 3 columns, but I don't know what the first month is. I just know it's month 1 orders. Well, what is month 1? Is that January? Is that 3 months ago? Is that some other arbitrary date? Who knows? Okay. We don't know what this really represents immediately off the top of our head. Now, we can add some extra metadata. As I said, we could have multiple aggregates in here. So you could actually add another one, which is pulling out the name of the month, the max month that we are pivoting, essentially what we are pivoting on really, to show us what they are. So we get 2 columns for each month, the count and the name of the month. So we can see we've got things like that. This reveals something a little bit interesting, because in 2018 there were no January orders. You can see that the offset for what month 1 is slightly different from each year. Interesting. So 2018 starts in February because that was the date of the first order, whereas 2019 starts in January. You might need to think quite carefully about how this is actually going to work. You probably want to filter your data in the subquery to actually make sure it's doing what you really wanted to do, and so on. So this can work in some scenarios, but a lot of the times requires a lot of interpretation and doesn't always, it's open to mistakes, basically. So finally, let's look at using dynamic SQL. So there's lots of ways you could approach this. What I'm going to do is first use listag to generate the values that are going to be in the results. I'll pull this out quickly, run this separately, so we get the output. So you'll see this gives us Jan, February, March. And then having selected those values into a string, we'll concatenate that into some dynamic SQL that we actually run. And if we just run this, print the cursor and so on, we can see we get something that's closer to what this is kind of what we want. But as you see, we got those little quotes around the end of it because we didn't provide aliases up here. And providing appropriate aliases for these is a bit fiddly and a bit tricky, and like I say, it really depends on what you're trying to do. So now there's other various ways that you can do this. There's some people who've written kind of like fully dynamic processes for this. You've got a function, you just pass it the queries in and it resolve it for you. I'd be careful with those. It opens up SQL injection possibilities. You need to think carefully about using those. But in general, we're still running 2 queries. If the result of this query can change frequently, so we're getting different columns every time we execute it, essentially, yeah, you're going to be running lots of unique queries, essentially, lots of passing overheads for your statement. Could be a problem, could really slow things down. Okay, so there's some techniques to look into. You can try them all out and see what you think of them. So I see there's a few comments and questions that come in, so let's just have a quick look at those before we move on. Okay, Uma Shankar, one more silly question. Can we use a dynamic frame value as variable in value clause? I'm not sure what you mean by dynamic framed value there. If you could kind of maybe give me a pseudocode example? That would be really useful. Thank you. Hachemi, is there a way to do dynamic pivoting with some gymnastics on JSON instead of XML? Not natively. We don't have like a pivot JSON clause, you know. Maybe one day we will, you know, if a lot of people request that, then potentially we could support a pivot JSON. I could see that people might find that more appealing than XML these days. And there's various JSON functions where you might be able to do something similar, but there isn't really a kind of out-the-box pivot, get the values as JSON data, Hachemi. So the answer is not directly, but you could probably kludge it together some way or another. All right then, a couple of other comments and suggestions. So Dennis, what if I want to pivot all values of the pivoting column, and I don't know what all the values in advance, and I want all these values to be columns, not an XML output? Or is it only possible with polymorphic table functions? I think it's possible to generate the table out of this XML with a polymorphic table function, but this is definitely a tricky one. If I want to pivot all the values of the pivoting column and I don't know all the values in advance, could you just like do a pseudocode example of what you're asking, Dennis? I'm not quite sure I understand what you're saying there. If you could, but just note you're saying they're on polymorphic table functions. So those of you who are not familiar, 18C, we had a new feature called polymorphic table functions. So polymorphic, changing, table function. What these allow you to do is at runtime essentially define the shape of the result set you want. So the columns that you and their data types. In theory, this allows you to make a dynamic pivoting function. And I have kind of built a prototype, but it suffers from the kind of parsing problem I was discussed earlier. Basically, if the columns are likely to change frequently, then it doesn't really take that into account. So let's take this query here. To do this truly properly, every time you execute the polymorphic table function, dynamic pivot, whatever it is, you need to rerun this query to define what your output is. That leads to kind of various parsing overheads and problems. There's lots of optimizations in Oracle database to limit the amount of parsing we do because it's CPU intensive and slow things down. So having to run a query every time at parse is not really a good thing to do. Now, in some limited situations, something like this, where we know we're always looking for the past 3 months of data, and therefore the columns themselves are only actually going to change once a month, we might be able to build in some kind of thing to force the old query out so we can reparse it essentially to get the new column headings. But basically, once we've defined the output columns for a particular PTF and it knows what they are, it tries to avoid reparsing it, which means it doesn't rerun this query to find out what the new columns are, and we don't get the full dynamicness that we truly want. So yes, in theory, Dennis, this is possible. It's a challenge to you or any of you watching here. If any of you are able to build this that works in a brilliant way, I'd love to see it, and I'm sure you'd make a lot of people happy too. And in certain scenarios where you understand the limitations, you might be able to use it as well, where the columns change infrequently. It might be okay, but a fully dynamic supports anything, anytime. Yeah, without running 2 separate queries, I don't have a good solution at the moment. Okay, so Dennis, I mean, exactly dynamic pivoting, and a PTF can be used, I guess, to convert an XML JSON to a table. I guess you're right in that you can use PTF. There's actually a few ways you can convert JSON to XML. I forget off the top of my head. There's a few ways to do it. But one of the problems, if we go back to the XML output, it's not what it's dynamically generating isn't elements with the column names. It's the values of them. It's the values of these elements You know, if this was called, if we had item bracket March in there, it'd be a lot easier because there's lots of tools that can inspect XML documents and say these are the elements in them and pull them out. When you're looking at the values in those, it gets a lot trickier. So yeah, maybe there's a solution, but I just don't know of it yet. And enough people ask this problem, have this problem and ask about it, that makes me believe that there isn't a good solution other than what I've talked about to you today. So Kofi, can we use XML table to convert the XML output to rows and columns? Yeah, in theory, yes, but in order to use that, we need, it goes back to the problem of needing to know what these values are, right? We need to know what is the result of this query, what values are we getting out of it to define what the columns are. And we're back to the running two queries problem or solution that I kind of mentioned a minute ago. So you probably can, but you end up doing something very similar to kind of something like this, you know, splitting two queries anyway, in which case you say, why bother with all that XML-iness, right? We'll just run two series and do it like this way. You've got the chicken egg problem. You just don't know what these values are until you run the query to know what the columns are going to become. So yeah, you're kind of stuck. Okay. So I mean, yeah, are the scripts going to be available? Yep. As I mentioned, I will save these into live SQL and add a link to the office hours page. So when I've uploaded the recording and so on, the scripts will be added to this, so you can walk through them too. So yes, there will be scripts available. All right then. Any other questions or comments on dynamic pivoting? No? Okay, so it's, like I say, there is no solution where you go, that's absolutely, I'm really happy with it, or at least my experience. There are various ways to kind of fudge it, but that's where we are today. So sorry about that. All right, so let's move on. So let's move away. Let's go back to where we know where the columns are actually going to be. Another problem, and I believe this relates to the question I was asked earlier about adding up, summing things up, and that's getting rows and column totals. So this is really common that people will do. You know, if you've sat with finance accountants, finance analysts with their Excel data, they got like the months across the top, rows, years, customers, whatever they are, down the side, and then they have got the column and rows totals. So we get something like this. So we get all these total results on the data. How can we do this, or can we do this with pivoting? You know, yeah, answer is of course yes. The question is, how do we do it? Well, there's a couple of tricks you can use. First up, to get the column total on the end, you can just add up all the pivoting columns, or do whatever operation it is that represents what they are. Usually it's just adding. And then to get the final total at the bottom, you can use a roll up of the implicit grouping columns to get that extra total as well. So this is pretty straightforward, but if we've got a lot of columns here, it can be quite fiddly. Like I say, if you've got 12 months of data that you want to show, adding all of those up can be a bit of a faff, and particularly sometimes you have to deal with nulls as well. So you've got to MVL everything, and it's just a bit of a pain to write. So there is another way you can do this, and that's so yeah, total column, total rows. You can actually kind of define these totals in your subquery by using rollups. So we'll have two rollups, one for the column totals, one for the row totals, or one for the row totals, one for the column totals. Get it the right way around. And whichever one that you want to be the row at the bottom, that's called total, you'll do something like this. And the other one, you'll just automatically kind of plop out an extra column on the end. However, to get this value total, we need to do a little bit of magic inside the query. So I will jump back over to a demo to show you how this works. All right, so row totals, pivot totals. So let's see if we can get, so this gives us the total column at the end, and rolling up by order year, we will get our final total at the bottom. So that gives us the output we were looking for. And notice we've made the implicit group by on order year explicit here with a roll-up. So that's pretty straightforward, but as I said, might get a bit fiddly if you've got a lot of columns here, or particularly if you're trying to do something dynamic and things like that. So another way you can do it, as I said, is roll-ups in the subquery. Now this looks a bit messy, looks a bit crazy, but this grouping ID column allows you to see when you're generating a subtotal. And if we are, we're going to tag that as total. And we'll do that for both the column that we want to become the row total and the one that we want to become the column totals. So you can see here, we've got total, totals, grand total, total by year, and totals by month. And if we run that, we will get what we were asking for. Kind of, right? Spot, if you're looking closely, you need to look closely at this one, spot the obvious problem here. So we've got, these are all fine, but if I just go back, pin that, and run the previous query, you might notice there's a bit of a problem going on here, a bit of a problem, right? This is this group, because we're calculating it in the subquery, these total roll-ups, this is the totals across the entire table, whereas we've only got 3 columns in our output. Looks a bit suspicious, right? Probably not what your users want. So we've got inflated total columns at the end. How do we avoid that? Well, we can filter the data in here, so where, whatever it is, date equals blah, 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 or we can sum up the totals individually. So when we sum them up, we get just the totals of these. So something to be a little wary of, a bit of careful of if you're going for these roll-ups. So this roll-up solution, the advantage of it is it's kind of generic. These total columns and rows just kind of fall out of the result. But if we haven't restricted the output, or if we excluded columns values, which would become columns from the results, these overall totals will be incorrect. Possibly not what you want there. So there's a couple of ways you can do that. Yep, so Hachimi, yep. Like I said, queries will be shared after the session. I will save them in Live SQL, come back to the Ask Tom Answer page after the session. I will share the scripts, okay? Last time I'm gonna say this, the scripts will be shared. So when you just come back sometime, I'll do that later today. I'll save a link on the page itself so you can come back and see that. All right then, so comment from Dennis. In fact, there are different tools that can be fed with, i.e. JSON document containing columns and datas, and they generate a table out of it. Data tables query plugin. To be honest, I do not see any issues if this to be implemented as a function in Oracle database. Yeah, and maybe I see things differently. Maybe we could talk about this offline, Dennis, if you've got some solution that you can think of that I'm not aware of. But they say enough people have asked this problem that makes me think there is not a simple, nice, easy solution available. Otherwise, someone would have done it by now. I could be wrong, but that's just my instinct on this one. Lakshman, sorry, I'm sure I'm pronouncing your name horribly there. Can we specify a select statement instead of hard-coded values in pivot? So we covered that a minute ago, talking about dynamic pivots. Short answer is yes, but only if you have an XML pivot. If you've not got an XML pivot, come back and view the recording later. So kind of, but not really. All right. Okay. All right. So that was what I wanted to cover on pivot. What if we want to go back to do the opposite? We've got some columns. We want to come back to rows. Well, pretty straightforward. We just do an unpivot, right? And again, there's 3 things we want here. So we've got a value column. So that is a column that's going to store the values from each row that we have unpivoted. We're going to have a column that stores the names of the columns we're unpivoting. So this first one stores the values. The second part stores the names of the source columns. And then finally, we've got the columns that we're actually going to unpivot. One thing to note about those columns is they must have the same data type. So if you're trying to unpivot incompatible data types, you're going to get an error. So similar to pivoting, quite often you will want a subquery to pre-process the data. In this example, just convert everything to a string, like just to char everything to actually be able to do what you want. So quick demo on unpivoting. We're getting close to the hour, so I'll whiz through this fairly quickly. So let me just check I've got this right. So I've pre-pivoted the data. Let's imagine I've got this table where I've got the years and months already, and I want to convert these months into rows. So what I want is a table of month, year pairs and the number value for those. So we'll unpivot orders. Excuse me. So that's going to store these values here, what these numbers are. Sale month will store the column names and the names of the columns that I'm unpivoting. So notice I'm only unpivoting 3 of them, again, partly because I'm lazy and partly to kind of show you this effect, right? You can see we've still got all the unpivoted columns in the results, and we've only got January, February, March as actual rows in here. Probably not what you want. So either you need to specify all of them, or you need to use a subquery to kind of restrict which values you're actually unpivoting. So we can do that. We can, let's go back to the orders table. Let's imagine we've got this table and we want to unpivot all the columns. So we want kind of like a, can't think of the word, each individual value as fields for each row. Now notice these are all different data types. So if we try and run this, we're going to get an error. Doesn't like it. So we need to convert them to strings, to char them all, so we can get that kind of individual field value view of that data. And we can unpivot multiple things as well, a bit like we can pivot multiple columns, you can unpivot multiple columns. So here we're saying unpivot pairs and months. So January, February becomes one row in the output. So we say, and we've got 2 columns, month 1 and month 2. So how do we know what month 1 and month 2 are? Well, they're the values, January and February. So month 1, January, February. For the second one is March, April, January, February, and so on. Doesn't make much sense in this example, but there are situations where this is kind of useful. So you can unpivot pairs or triplets and quadruplets of columns as well. Okay. A few other things I want to cover off, so I'll just charge on for the minute. Next thing is dynamic unpivot, right? So dynamic pivot, as I said, it's not a great solution. Dynamic pivot, however, does work, and we already talked about it a little bit with Dennis, polymorphic table functions, and this does actually work really well. So there's a live SQL link for that there. Again, I'll include it in a link to it in the scripts or on the page later, but I'm not going to go through it because it's a bit too much detail for a session we've already spent 50 odd minutes discussing. So you can do a dynamic unpivot quite easily. Dynamic pivot hard, taking rows turning into columns, taking columns turning into the rows. That is very doable. All right, a couple of the things I wanted to cover off, and then we'll have a little bit of time for questions at the end. Well, now next, this is an interesting question. Can we switch rows and columns? Essentially, transpose the whole table, kind of take it along its diagonal and flip it over. So we've got months along the top and columns, years down the side, have years as the columns and months as the rows. Flip over the rows and columns. The answer is absolutely. You can chain together pivot and unpivot statements like this. The input of each is a table and the output is a table, so you can just keep chaining them on together. And I've just got, I'll do a very quick demo of this. So we've got my year, month sales, and I've got the column, the months across the top. Whoop. Got months across the top and years down the side. I want the years to become the columns and the months to become a rows. I can just chain together an unpivot and a pivot, and voila, there we go. We've flipped them over. I'm not sure there's many situations where this would be particularly useful. Probably more of a display thing as much as anything else, but it is useful to be aware of. If you ever encounter this problem, people do ask me this occasionally, so you can do a transpose, flip the two of them over. A couple of the things I wanted to cover off, and then I'll see if there's any more questions before we finish up. So we've talked about turning columns to rows, rows to columns, and a lot of the times this is done for display purposes, so you can see the results in kind of tabular form, which particularly finance people like to see. They like to see the months or years or weeks or whatever is across the top, and then whatever the other value is as rows down the side. There are some other reasons, or some non-obvious reasons, that you might want to use Unpivot in particular. So, and that is searching for dates, gaps and overlaps in dates. So really common design pattern is to have table with columns like this, start date and end date. And we've got a series of events in there. What you want to do is you want to find if there's any time periods where there's no registered event, or if there's any 2 or 3 whatever events that overlap. So you can see, kind of see if you look at this, we've got event 1 finishes on the 3rd, event 2 starts on the 6th, so we've got a gap there. And again, event 2 finishes on the 10th of January, event 3 starts on the 8th, so those two overlap. We want to find those. Unpivoting is the starting point for actually being able to process these or see these with SQL. So if we unpivot those two, start date and end date, and sort by the resulting date, we get some values that look like this. And just looking at the data, you can see we've got end date, start date, 3rd to the 6th. That tells us there's a gap in there. Also, if you've got 2 or more consecutive rows, which are both start dates or end dates, that also tells you you've got an overlap. Now, turning this into a final report that actually, details all the information about what those values are and where they fall, that's an exercise for another day. But the key thing here is this is the start point, and hopefully you kind of get the concept that this makes it relatively easy, at least visually, to see where the problems are. We can see there's a gap here. We can see there's an overlap there quite easily. So unpivoting as a way, if you've got start end date columns on a table, to search for gaps and overlaps. Another thing you might want to do is a column level comparison of tables. So you may be familiar, if you got 2 tables and you want to see what rows are the same or different between them, you can use the union, minus, intersect functions and so on to do the comparison. That tells you the entire row is different. Sometimes you might want to say, well, generally the data sets are pretty much the same, but we know, or we expect, there's probably a few columns here and there which are slightly different. Tell me what those columns are, right? And what the values are in each table. If we use Unpivot, if we unpivot tables first before doing our comparison approach, you can then see quite easily where the different column values are. Again, the full details of this is way more than we've got time for at the moment. So I will share the script so you can pick it apart and play with it later. But if we do something like this, you can see for this primary key value, we've got the 2 different values. We've got different values for these other columns. If any row is missing in one data source, or present in one source but not the other, you'll get all the columns listed for them. So this is useful, like I say, if you just need to see 2 data sources which are primarily the same, you need to see which column values specifically are different, so you can give that to the end users to sort out, fix their data, which is the correct value, figure it out, update your systems properly. Alrighty then, so that is the stuff that I wanted to cover. We're pretty much on the hour. I can hang around for some more questions if anyone has them. If you've got some questions, please put them in Q&A, as I say. While you're doing that, I'll just point you to some further reading links. So I've got this blog post. It's probably by far and away my most popular blog post ever. It's like the big details of how to convert rows to columns and back again. Talks about most of the stuff and some other details that I haven't quite covered. So check that out. If you Google for it, it's pretty much the top hit. I've also referenced Stu Ashton's blog post. So he's a guy who knows a lot about SQL, and he's talked about some of these other use cases that I mentioned at the end, searching for gaps and overlaps in data, comparing tables. He talks about those a lot in detail on his blog post and has some other thoughts and useful information about pivoting, unpivoting, and SQL in Oracle database in general. So I'd recommend checking that out if you want to know more or deep dive into these with a bit more information. Alrighty then, with that, we are on the hour. So I really hope you enjoyed that. More importantly, I hope you learned something. Thanks for joining, and hopefully we'll actually all be able to see each other in person sometime in the not too distant future. All right, goodbye.